angles and their properties for triangles and quadrilaterals, including parallelograms, in under 180 seconds. Since the angle formed by a line is 180 degrees and the whole is equal to the sum of its parts, the measures of angles A and B below add up to 180 degrees, meaning the measure of angle A plus the measure of angle B equals 180. So the measure of angle A must be what remains when you subtract the measure of angle B from 180 degrees, so that measure of angle A equals 180 minus the measure of angle B. Similarly, the measures of the supplementary angles B and C add to 180 degrees as well, so the measure of angle C is equal to 180 minus the measure of angle B. Putting these equalities together, you see that the measures of opposite angles A and C must be equal since they're both what remain when subtracting the measure of B from 180 degrees. So we have measure of A equals 180 minus the measure of B, and the measure of C is equal to 180 minus measure of B as well. So the measure of angle A is equal to the measure of angle C. And if we add angle D to the picture, we can see that its measure will also equal that of its opposite angle B. Now, if we were to move the segment of the depicted horizontal line through the line that crosses it, we do not change any of the angle measures. But any line that's parallel to the horizontal one can be gotten in this way. So, renaming the new angles, we can get more angle measure relationships when parallel lines are cut by a traversal. So the measure of any angle is equal to the measure of its corresponding angle, which means the measure of angle A is equal to measure of angle E, measure of angle B is equal to measure of angle F, measure of angle C is equal to measure of angle G, and measure of angle D equals measure of angle A. We can also see that the measures of alternate interior angles are the same as well. So the measure of angle A is equal to measure of angle G, and the measure of angle B equals the measure of angle H. And the measures of alternate exterior angles are also the same. So the measure of angle D is equal to measure of angle F, and the measure of angle E is equal to measure of angle C. Now, moving the segment of the depicted diagonal line across the parallel horizontal lines, we again do not change any of the angle measures. Since any parallelogram has four sides and parallel opposite sides by definition, we can form whichever parallelogram we want this way. Here we could have drawn the original lines to match the measure of its vertex A, and then move the horizontal line up to match the length of AH, and the diagonal line left to match the length of AI. And doing so allows us to see that the opposite angles A and J, and I and H of this, or any parallelogram, have equal measures. So the measure of angle A is equal to the measure of angle J, and the measure of angle I equals the measure of angle H. And since angles I and J, and H and A on the same side, each add up to 180 degrees, the angle measures of the parallelogram add to 360 degrees. Now, if you have a triangle and draw a line that's parallel to one of its sides, say BC, through the angle formed by the vertex A opposite to it as follows, then you will see that the measures of angles A, D, and F have to add up to 180 degrees since they split the line. Mainly, the measure of angle A plus the measure of angle D plus the measure of angle F equals 180. But as noted before, the alternate interior angles will have the same measure, so the measure of angle B equals the measure of angle D, and the measure of angle C is equal to the measure of angle F. By substitution, we see that the measures of the angles of a triangle add up to 180 degrees. So the measure of angle A plus the measure of angle B, which was substituted for D, plus the measure of angle C, which was substituted for F, is equal to 180. And then, since connecting two opposite angles of any quadrilateral, which may not be a parallelogram, forms two triangles, its total angle measure will be 180 plus 180, or 360 degrees.